Okay, starting with problem number 11, you're given a function. It's a cubic function. You're given the graph, figure 2, and they say list the candidate rational roots of this. And looking at the leading coefficients 2, the constant is 3. So let's write this down. It's going to be plus or minus a set of numbers. That set of numbers is going to be, let's see, the top would be the factors of 3. That's 1 and 3. The bottom would be the factors of 2, which is 1 and 2. I'm willing to accept this as an answer. However, it would be nice if you wrote down the actual list. It's a short list. It's 1, it's 3. This is plus or minus, by the way. Let's see, we did 1 and divide by 1, 3 divided by 1. Now it's going to be 1 divided by 2, which is a half. And then 3 divided by 2, which is 3 halves. All right, both answers are acceptable. All right, factor it completely. Well, kind of looking at it, I see roots on it already. I'm just going to write this down. This could be wrong because sometimes it's very deceptive, but I want to go through checking it. Now, looking at it, I'm going to say it looks like one of the roots is going to be 1. So I'm going to say x minus 1. I'm going to say the other root, by appearance, looks like it's minus 3. So that means x plus 3. Now, the other root I'm looking at, this guy right over here, I'm going to make a guess at it be 1/2. All right, so x, let's see what that would be. If it's a half, right, it would be x minus 1/2. Now, granted, this is not totally correct, and I'll tell you the number is why. The leading coefficient is not 2. So what I want to do is rewrite it by multiplying this thing by 2. All right, I'm going to cross this one out and multiply it by 2. Now, what am I multiplying by 2? This factor over here. That would be 2x minus 1. I want to go through checking it, though. All right, the reason for checking it, maybe you make a mistake. Maybe you're writing the wrong answer down. What do you get over there? Well, I'm going to multiply the first two factors together. That's x squared plus 3 minus 1, which is plus 2x. And then you get minus 3. The second factor, I haven't multiplied that yet. What are you going to get there? I'm going to distribute this across those 3 terms. That would give you 2x cubed plus 4x squared minus 6x. Distribute the minus 1 now. What do you get? Minus x squared. Let's see, minus 2x, and then you get plus 3. Add it all together, you get 2x cubed plus 3x squared. Let's see, minus 8x plus 3. Now, if you look back at the original function, you want to make sure they match up. Let's just go through that. I'm looking at it right now. I do see the 2x cubed. I do see the 3x squared. I do see the minus 8x, and I see the 3. All right, that question's done. Wasn't a bad question. I thought it was kind of easy to do that one. All right, let's go to number 12. And what they want me to do is what's not in the domain of the following. So as I'm doing this over here, I'm going to write the domains of these things down over here. The domain of this over here is going to be from 0 off to infinity. Now, the domain of this thing over here is going to be all the real numbers. This is the domain of this guy, except x can't be 0. All right, so let's write this down. G of f of x. All right. Now, yeah, it's time to think. It's saying, who's f letting in? And f is letting in all the real numbers. And what does he let in? He lets in 1 minus 1 over x. And the domain of that's what f of x is, by the way, is going to be all the real numbers. However, x can't be 0. All right? Then he's going to pump numbers out. And this is the thing that people often get confused by. And I realize why they're confused by it. What we're trying to do is we're trying to restrict this guy over here to being greater than or equal to 0. So I'm going to write that down for you. We're looking to make 1 minus 1 over x greater than or equal to 0. All right? I'm going to solve that inequality. By doing that, I'm going to, what we learned in the first week of school, that's going to be x minus 1. I can put a number line down, and that number line is going to start at, let's see, we got a 0 on the bottom, and we got a 1 over here. 1 certainly satisfies it. If you took a number after 1, that would also satisfy it. Like, for example, 2 would satisfy that inequality. And if you took a number below 0, like minus 1, plugged it in, that would also satisfy that inequality. All right, so looking at it, I'm going to say, kind of looking at this over here, I'm wondering which number can't come in. And I know minus 1 can come in. All right, when I'm saying about this over here, I'm looking at my little list over here. I'm going to say minus 1/2's okay. It's over there. It's all over there. But 1/2's not. Right? So this is the one I'd circle. right? This can't come in, all right? So which of the following is not in the domain of g of f? I would say 1/2. Someone says, why is that? If you put 1/2 in, right, so f of 1/2, what's it going to give you? 1 minus 1 divided by 1/2 is 2, which is minus 1. Minus 1 cannot be given to that guy, all right? So that's number's not coming in. So that's number 12. Let's go to 13. 13 is a rational inequality, right? Should be easy to solve. We've been doing this since week number 1. That's 5 minus 3x, x minus 3. I subtract 1 from both sides, and 1 is the same thing, at least conditionally, x minus 3 over x minus 3. And that's going to be greater than or equal to 0. Common denominator, that's x minus 3. That was the whole point of it. What do you get there? Well, you get 5 minus 1 minus 3, which is 8. And then you get minus 3x minus x, which is minus 4x. What goes down? The number line goes down. On the number line, 2 numbers go down. One of the numbers is going to be the number 2. That's where the top takes on a 0. And the other number is 3, where the bottom takes on 0. Now, 2 satisfies the inequality. I'll shade that in. 3 doesn't, because it's undefined there. And all you're going to do is now take a test point. Like if you went after 3, put a test point down, like let's say 10, you get a negative number, and they're not greater than or equal to 0. If you took a number below 2, like 0, you would get positive on top, negative on bottom. I wouldn't shade that in. So then the question comes is, what happens over here? Let me just talk about 2.5. If you try 2.5, on the bottom you get negative. On the bottom, you'd get 4 times 2.5. Well, 4 times 2 is 8, and then 4 times a half is 2. So it's 8 minus 10, which is a negative number. A negative over negative is a positive. This gets shaded in. That's greater than 0. So what do you get over here? We're going to put it down. We got a graph of it. This is the graph. And let's put the interval down now. The interval is going from 2 to 3. All right, let's go to 14. That's the very next page, right? Yeah. Another multiple choice question. This one says g is the inverse of f. And then they say, what's the value of g of 2? Well, let's go through finding the inverse first. And you get y equals the square root of 2x plus 4. Square both sides, you get y squared. Whoops, I'm sorry, I forgot to do something. Let me get my eraser out. I gotta find my tools over here. Let me see where my eraser is. I don't know where my eraser went to. Let's just cross it off then. All right, what do you get over here? X equals the square root, 2x plus 4. I'm sorry, 2y plus 4. Another little mistake there. Square both sides, x squared, 2y plus 4. You're trying to solve for y. You get x squared minus 4 over 2 equals y, which is the inverse of, which is the inverse of f, right? What's this called? They called it g. Now, what's their question? Their question is, what's g of 2? And if you did that, what are you going to get? On top, you get 0. On bottom, you get 2. What is that going to give you? 0. Correct answer being C. All right, let's go this one over here. So be so much familiar. We've seen these before. We've actually done them in class. Really, almost, I think it's an identical problem, by the way. It says the range and interval notation. I realize for some students this is a struggle problem for them, but I'm looking at the picture, and this over here and this over here, it's an even symmetric problem, by the way. And you see that in the picture. This is minus root 5 over 2, and this is going to be root 5 over 2. And what I'd like to know is what f is at that number. Now, whether you're evaluating minus root 5 over 2 or root 5 over 2, it's the same thing. And this is for me to get the range. You plug it in, and when you put that to the 4th power, you can get 25 quarters. And then you can get minus, well, 5 times that thing squared is going to be 25 halves. And then you get plus 4. I'm going to get a common denominator. That's 4. You get 25 minus 50 plus 16. 25 minus 50 is minus 25 plus 16 over 4. What do you get there? Let's see. You're going to get minus, this is going to be 4 on the bottom, and then you're going to get 9. So this is minus 9 quarters. All right? So what's the range going to be? The range is going to be from everything from minus 9 quarters, inclusive. It actually touches it. By the way, this is also minus 9 quarters. That's a point, and it goes off to infinity. That's the range. Yes, it did require some arithmetic. It was a good idea to be able to do that arithmetic. The next thing says the intervals where it's increasing. Well, I'm looking at the picture, and I'm going to say it's increasing from minus root 5 over 2 up to this point over here. So it's increasing here, by the way, and that's up to 0. Is it increasing somewhere else? It is, from here off to infinity. So where's that going to be? Root 5 over 2, whoops, comma, infinity. All right, let's go to the third question. Where's it decreasing? Well, minus infinity up to minus root 5 over 2. That's this region over here. It's decreasing there. And it's also decreasing over here, by the way. So where's that going to be? Union, and that's going to be from 0 up to root 5 over 2. So next page. Next page, it says the domain of this guy over here and the range. I will say the domain's pretty easy to come up with, by the way. I know that x must be greater than 0. That's coming from this over here. If I said 0, that would be an illegal number to use. It would be a division by 0. This guy's not causing any problems over here except at 1. So I'm going to say, if you're looking at it, I'm going to say, starting at 0, and it goes up to 1, and then it's okay over there. Okay? So I'm looking for that. And someone says, where do you see that? I see that in 2 locations. I see that here, and I see that here. All right? Now comes the next part, which is the troublesome part for some students, which is the range part. But it's only 2 choices now. So if you look at the choices, I'm saying this choice over here would be a bad choice. And the reason for that, f of x could never equal 0. Just look at this over here. This can't be 0. So this must be the correct answer, which is A. All right, let's go to the next one. The next one says, find and expand a 4th degree polynomial. I know what a 4th degree polynomial looks like, with real coefficients that has the following roots. Let's write this down. F of x equals x plus root 3, x minus root 3. So I'm finding it now. And now they give me this root over here, which is x equals 1 plus I, and x equals 1 minus I. All right? So what do I write down? X minus 1 minus I. That's from this guy over here. What's the next one going to be? X minus 1 plus I. All right? We found it, and that's certainly worth something. You did find it. All right? So I'll put a box in this here. This is the finding. But they also asked me to expand it. All right? Find and expand. Now, if you want to put a different leading coefficient, you can down, but I don't think I'd recommend it. I'm just going to start to multiply it out. And the way I do that is I do it in pairs. I'm going to do this pair first, which is a relatively simple pair to do. It's going to be a difference of perfect, I shouldn't say perfect squares, x squared, the root 3's disappear, and then you're going to get minus 3. The other guy's a little more complicated. And by that, what I mean is I have to multiply that through, and what do you get? I'll do it in stages. It's x squared. I'm distributing this across those 3 terms, minus x, let's see, plus xi. And then what do you get? I'm going to do the minus 1 now. You're going to get minus x, and let's see, plus 1. I'm distributing this minus 1 now. And then let's see, minus I. All right? Let's distribute this. What do you get there? Minus xi. Let's see, plus I. So I'm lining things up, by the way. And then you get minus I squared. All right, let's write that down. That's x squared minus 3. You get x squared minus 2x. Xi disappears. 1 minus I squared is going to be 1 minus a minus 1, which is 2. And the i's disappear. So I got that part. I'm expanding it, but expanding is not fully done. I need to multiply it out now. And I'm going to distribute one term at a time. So x4 minus 2x cubed plus 2x squared minus, let's see, whoops, I did that again, didn't I? So minus 3x squared plus 6x minus 6. Let me pull this all together for you. x4 minus 2x cubed minus x squared plus 6x minus 6. Put a little box in that. All right? So x4 minus 2x cubed minus x squared, 6x minus 6. All right, let's go to the next question. Another multiple choice question over here. It says, if f of x is this and g of x is this, find a composition. It doesn't look too bad. So f of, what's g? It's 3x minus 1. What does f do to it? Well, it multiplies it by 3. I'm sorry, it multiplies it by 2. 2 times 3x minus 1, and then it adds 1. What do you get over there? 6x minus 2 plus 1, which is 6x minus 1. That's letter C. Let's go to the next one. This is a complex arithmetic problem, and there's only 2 things you really need to know. And those 2 things you need to know is what I squared is, and I squared is just simply minus 1. And the other thing is to know that I is really just the square root of minus 1. Well, I don't see the square root of minus 1 in it, so I'm not really worried about this. All I'm looking for is I squared. That's all I'm looking for. So let's write this down. You're going to get 2I squared to the 30th power. That's done. Let's go to the next one. Minus 3I squared to the 75th power. That's done. Let's do the next one. Minus 4I squared to the 41st power. That one's done. Now, next one a little more complicated. I do see 5, and I do see an I, but then I got 108 i's left, so it's going to be I squared, and I want to make them 108 of them, so that's going to be 54. All right? Let's go to the next one. Minus 6, a little more complicated, and I'm on this one over here. I'm going to say there's an I there, and there's also an I squared there. Now, again, there's going to be 61, so now I'm looking at, I need this to be 30 to make it 61. Let's write this down, carefully. Minus 1 to the 30th power, minus 3, minus 1 to the 75th power, minus 4, minus 1 to the 41st power, plus 5i, minus 1, 54, minus 6i, minus 1, 30. All right? Now, minus 1 to the 30th power is just simply 1, so this is going to be 2. The next one is minus 1 to the 75th power, which is negative 1, and negative 1 times 3 is plus 3. Next one, minus 1 to the 41st power is going to be a negative 1, and that's going to be plus 4 now. And then what do you get? Minus 1 to the 54th power, that's going to be a 1, so I get plus 5i. Let's see what you get over there. Minus 1 to the 30th power is going to be 1, and it's going to be minus 6i now. All right? What do you get there? Let's see. 2 plus 3 plus 4, that's going to be 9. And 5 minus 6 is minus 1. So 9 minus i. All right, this one over here says find the absolute value of the sum of the solutions to the equation. Well, it's a quadratic equation, and let's solve it and find out what the roots are. That's going to be 4x squared. Let's see, plus 12x, minus 6x, minus 18 equals 14. 4x squared. Let's see, 12 minus 6 is going to be 6x. I'm going to subtract 14 from both sides, and that would give you minus 32. That gives you 0. I'm going to divide by 2 to make it easier for me to factor the problem. And I'm looking at that. I don't think I'll be able to do that with the my finger numbers. So I'm going to use quadratic equation. And what's that going to be equal to? Let's see. Minus b, that's minus 3, plus or minus. In the bottom, you're going to get twice the a, which is 4. And over here, the b squared is going to be 9, minus 4, times a, which is 2. And then the c, which is minus 16, so I'll just put plus 16 over here. Now, what I know about this problem over here, they asked me for the sum of the roots. I really don't need to compute much else on it, so I'll write down what the 2 roots are. x1 is going to be minus 3 plus the square root of that number. Maybe we should do the number then. So you get 9. 4 times 2 is 8. And 8 times 16 is going to be 80 and 48. That's going to be 128, 137. And that's over 4. That's one root. What's the other root? The second root? It's going to be minus 3 minus the square root of 137 over 4. Now, what do they want you to do? They want the sum of the solutions. Let's write this down. x1 plus x2. What's that going to be? Well, what's nice about that? The roots disappear, and you get minus 6 over 4, which is minus 3 over 2. But what they want is the absolute value of that number. And the absolute value of that number is just 3 over 2. We're done with this? I believe we're done with it. Yeah, we're done with it. Thanks so much for paying attention.